Alright, time for another DraftPhysics.com, DebatePhysics.com also, video presentation. Again, asking the question, why do you believe the stuff they say? Physics says, and I argue, come on, it doesn't take much thinking at all to say, is that really the best you could come up with as an answer? Can't do any better than that. Anyway, so I thought I would talk about why I took the time to think about all the crap they say. And frankly, some of it I thought about for 60 years. It took a long time to get the right answer. Obviously, you have to, concentrate your focus. You can't just in some vague way say, okay, they drew this thing. All right, and said this is a photon, right? And my brain just said, no, that's not a photon, whatever that is. This thing with a magnetic field going this way and a electric field going this way, and the it's bad enough just to even have one of these curvy little squiggly lines flying through space. Like, how could something fly crookedy? My brain just couldn't make any sense out of it. How this is Pixie. This is Tinkerbell. Probably couldn't even do this. Okay, it's really fancy flying. And the idea that some force coming from here or something was causing it, or something doing this, or well, that doesn't make any sense because photons are all by themselves out in the middle of nowhere in space flying around. How could some other field thing be making it? It doesn't make any sense. So, I was like, oh, all right, I guess I'm not going to understand physics. That's kind of what I was, it's just, this just doesn't work for me. And this is in grammar school, and one of those little key experiments was the cloud chamber you do in grammar school. We actually did it, and you put the little radioactive thing there in your little cloud chamber, and all these little straight lines fly out, and it just kind of screams, this universe is straight lines. The universe doesn't do this stuff. It does little straight lines. Straight lines make a lot of sense, right? And that's sort of also the push-pull argument. I don't think I was there yet, okay, to say I can't understand a pull, but I guess I certainly understood things banging into each other, and could understand that something has a disease, okay, and it could give the disease to something else. I could understand me giving away money. I can understand lots of ways that whatever we call this energy stuff, that you just exchange it, and that sort of, that kind of circle you could understand, that what comes around goes around, that you affect something over here and you've changed the energies in motion, and eventually it might leak back to you again. It's a reoccurrence thing. So I don't know what age I was either when I first occurred to me that I could be made out of a dinosaur's anus, or something unspeakably. That I could have atoms, that actually, the atoms are still the same atoms that were around billions of years ago, and that I could be made out of atoms that were doing all kinds of creepy things, part of all kinds of creepy adventures, and they just cycle around, so that that all made sense to me. And then there was the basic thing, the most basic of all things. Physics says this is what an atom was, right? And it has this diagram of these electrons swirling around, It's just, come on. It's electrons swirling around, just conveniently. And it's always, their diagram was always, I'm told, okay, that nothing can orbit in an orbit, a nice circular orbit, it's always some sort of bent orbit. And that always seemed just circumstantial, that, you start off crooked, you end up crooked. But if you actually made a perfect orbit, it would stay a perfect orbit. But anyway, And so, so they had this diagram of an atom, and you're saying, that, it seemed to make so much sense that chemistry would say to you that the way you end up combining two atoms is that you have an electron that they're sharing, okay, that both of them need this negative, okay, to balance their positives. And but then they had this thing, they'd say the electron was doing this. This is their diagram of reality, that this is how it's sharing the electron. So this was a big, oh, no. Can't be the truth. Come on. How is that sharing? I mean, when the electron's over here, why is this hanging around? I mean, this would be saying, I'm out of here. I'm you're not any use to me, okay? You're not producing anything I need anymore. And only for this little tiny split second is it actually in a useful location to both. And the rest of the time it's in some location that isn't doing either one any good. So that didn't make any sense. I mean, you can't... And then you'd have to have all this speed control because you find out that orbits can't be too fast or they can't be too slow, or you crash, you just spiral into the nucleus. So how does all that work? And then they got up to this. Then they started telling me about some kind of quantum leap where it just instantaneously pops into a different orbit. And that didn't make any sense. And then they were saying the energy levels are stronger on the outside than they are on the inside. And I was like, that doesn't make any sense. So, it just became so doubtable that everything they say you can't trust because, that can't be, I don't know what the truth, I didn't know what the truth might be, but I knew this wasn't it. This ain't the right answer. All right, and then they would talk about the magical strong force and all of that stuff, and none of that made any sense. So yes, it was many years ago. I can't say how many years ago, but it was many years ago that it occurred to me anyway that the strong force could easily be understood, based on their own model. I should find my red marker because, I think we need colors for this one. All right, color enabled. So, they would talk about the fact that you had this idea of this proton and the electron, and the idea is that these protons, there's just no way you could smash up two of them together. Now, the other part that bothered me is they didn't seem to talk about electrons having the same problem. And, even though they say protons are heavier, they have the same charge. It's an equal amount it ends up being of total charge produced, let's say, by protons and total charge produced by electrons. Now, you could argue that maybe the universe the protons are in is a different size than the universe the electrons are in, and some sort of dimensional thing. And, I don't know. Maybe there's some way you can make sense out of that, but I was sort of stuck with the idea that if the charge is the same, then their size has to be same, because I'm sort of saying charge is a visual thing. It's almost like these things must be able to see each other, to know which way they're supposed to move. And so I didn't necessarily say they were seeing what I eventually learned they were seeing. But anyway, so they would talk about the strong force for the protons, and they never talk about a strong force for the electrons. That somehow you could smash electrons together, and it was somehow easier to do than smashing protons together, and that part didn't make any sense either. So, and then a key moment is when I found that they were actually arguing that the magical thing called a neutron, which was, just something that would, again, just has a label, and they say it's neutral. Well, I mean, you could make it neutral two different ways, right? I mean, you can make something sweet and sour by adding sour and sweet, So maybe the neutron is... Well, anyway, so eventually it was... I found that physics basically said that this thing called a neutron was really a dipole. I mean, that if you broke one, you'd find out that it had both the electron in it and a proton in it. That both elements, existed. So it was really just a dipole. It was really just the first and smallest, the thing that has both, elements, and you would assume one element's on one side, one's on the other side. And you could sort of understand things like, well, if I spun it real fast, you wouldn't be able to see what pole it was, right? It would just mix the two colors. So if it was actually blue and red and I spun it, it would just be purple, right? So maybe neutrons are just that. They're just these two things stuck really close together. And so it, and then even without that piece of knowledge, I had already said to myself, well, what happens if I just stick one of these electrons in here? I mean, haven't I solved the strong force problem? I mean, isn't that problem now moot? Because we know the protons really like electrons. So what's the problem? If they can't see each other and you got an electron in between the two, haven't you solved the strong force problem? I don't really have to use a whole bunch of, I don't do have to do a bunch of work to smash these two protons really close together if there's an electron between them, right? Because the electron will do the work for me, so to speak. So that didn't, gel entirely, that you have some special strong force and you're going to use that as an excuse for the energy inside of an atom. But clearly it's not enough energy, with the little swirling electrons. There's not enough energy in swirling electrons to account for nuclear bombs and such. You gotta have a lot more than just the speed of electrons. You're breaking the solar system, and all of a sudden you let Pluto and you let Jupiter and you let Saturn fly out. It's not nearly enough energy for a nuclear explosion or something, so you have to let something more than that out. And you have to have something under a tremendous amount of pressure. And then that's the other fact they tell you. Basically they give you a nice clue, and they tell you that all these atoms, and there's only like 100 of them, right? There's a lot less if you just count the ones that actually are survivable. There's only 100 of these geometric arrangements of this crap that can survive outside the sun, right? The sun inside a very high pressure cooker is the only place these things are can make. You can't, we can't do the alchemy thing in any real way. We can't just take electrons and protons and say, let's make atoms. Now, we might be able to get somewhere like that now with lasers and different ways of concentrating extreme amounts of energy. But that's the whole point, that you need this extreme environment in which these things can be shoved together, where you can actually get everything arranged and shove all these little pieces together. You need a huge amount of pressure to be, banging into this stuff to force it, into that condition. And so that made huge sense. So that's the one thing they got. Well, that makes sense, that you can only make these nucleuses inside the sun. And it would be basically the nucleuses, because you could always say, well, once I take a nucleus and I throw it out into the environment, picking up electrons is easy. I mean, it's like no work at all to find some electrons. So, to steal off of somebody else, you just bang into some other atom and you can steal an electron. So obviously, the electrons on the outside aren't nearly as important as the building of the nucleus of the inside. That's the real identity of the atom. So I guess that was another key kind of thought, was to recognize what defined an atom, a material, was the nucleuses. And that the electrons were important. You had to have some of them anyway. I mean, you could have isotopes where you were missing a few. But basically you needed to have the right number of these electrons. Yeah, you could be missing a proton, you could be missing, but it had to be close. Anyway, you can only be missing them obviously with the big elements. So all of that, I was sort of stuck with the idea that if an atom that's going to be sharing an electron, it's literally sharing it. So the point would be is that you'd have this complex nucleus, with this electrons and protons. So it's not made out of just protons. It's made out, those neutrons are basically providing the electron. So they're providing the medium. You're just adding another proton to the neutron, and you're creating an object that is survivable, and that you can geometrically create arrangements of that orientation. And that's what the nucleus was, and then the little electrons on the outside, and you literally share them. So two atoms would literally share the electron. It would stay in this position, and you'd understand that everything's could be jittering. This could be bouncing around here and there. So that would give you some idea of their probability fog. Is that the foggy part is that it's it's jittering. It's not in one place all the time, but it's pretty close to the same area. But it's literally shared, and the two atoms really can't go anywhere they want. If one atom turns or does something, the other atom's going to feel it, because it has to turn also. And so it connects all this matter to each other and creates the mediums, makes the water molecules stick to each other, and then forces them to drag each other around with each other. I mean, if they were just sharing, you could understand that it'd be breaking off and switching partners all the time. Man, it can't be that easy to switch partners. But obviously that's what water molecules do. It's they're bound, but they're not bound so tightly that they can't, another one can't bounce in, and they stick to the other one instead of this one. Then they stick to this one instead of that one. Well, anyway. But then you get into structures, and the fact that the molecules themselves end up being geometric when they're in solid form or in, something other than a gas. That they have to actually take a certain shape to solidify, or to, if you take out energy, you cool them. I guess it's a simple thing to say. You take out any jittering energy, they will fall into patterns. And so, like with ice crystals, they end up being kind of a circle, where the atoms form a hollow mechanism, and that's why the ice expands instead of contracts, is because it basically is trapping nothing inside air. So just giving you a reason why. And then everything I did in the last few years was all the little bits where you start making, you start thinking about the simpler model, and pieces start falling together. And so, a big piece, say whatever it was, 3 years ago or so, well, the first step was 10 years or so ago, where it seemed obvious to me that there is this stuff called force, and they're all moving the same speed. So all the forces are the same. It's the same speed. So you got to say, well, everything that's happening that we call a force, it's probably got to be the same stuff, and it's just in some different arrangement. So that's when I decided that photons were just a frequency. That's how we know them. We only know them because there's this thing called a period, between them. And, people call it a wavelength, different crap, but I mean, it's just basically a pattern. There's stuff, then there's no stuff, then there's stuff, then there's no stuff. And that sort of made sense out of the idea of, a radio wave is this gigantic thing. And I'm saying, well, this gigantic thing can't be, something 10 miles long can't be flying through space. I mean, it's ridiculous, almost ridiculous to imagine how something that long could go somewhere and then hit a certain, it just doesn't make any sense. And so it's so much easier just to say, well, instead of making the empty space the thing, why don't I make the why don't I make the event tiny, and the event just tells you how far you are. You have empty space, and then you have event, and that makes so much more sense. That the frequency is just the distance between, the wavelength is just the distance between events. Little corpuscles hit. All right, and that made sense. That's what photons are. It's just a pattern. And then I, learned something about polarization, and they found that this, if I make a film this tight, the photons get through. If I make a film this tight, okay, they don't get through without all breaking, without creating a lot of fringes. So seems that we can kind of tell how big the photon is based on how big a grating it can go through. And so that sort of was another giveaway that polarization was big. And so whatever's hitting a surface isn't how they describe it. So, they give you a diagram. They say, okay, here's an atom, and then they'll draw the electrons, and then they'll say a photon comes out. They'll draw a squiggly line of a photon coming out. And I'm saying, no, how can that be possible? It's polarization, okay, of a photon. That is, we've tested it. You can tell how big a thing it goes through, an opening. So we know this photon thing has to be, 1,000 atoms. So it's not, 500 anyway. 500, it's 500 atoms worth of polarization, whatever the polarization is, right? So I figured the polarization was easy enough to explain as just being out of alignment. So they're running parallel to each other. All right, and they're a little bit out of alignment, and that's the polarization. So, and then that just ran into, oh, well, that explains antennas, right? Because antennas are, so obviously what they're kind of doing. I mean, the electricity starts at the bottom of the antenna, right? It starts down here. And what does it do? Well, it goes up the antenna. Yeah, that's what it does. And so it seemed kind of sensible that, well, if I'm going at the speed of light, then I'll agitate an atom here first, and then I'll agitate an atom here, and then I'll agitate an atom here. And that agitation of when I get to the atoms could match the polarization. I mean, this distance, could equal the distance, the time it takes for the electricity to travel across a crystal of atoms, inside of a metal. And the crystal is what's producing the photon. So, wow, that started matching. So just one thing leads to another. But I guess let's get back to the most elemental piece. See, it's really hard to put all the little pieces together, but just from the how they built the atom, okay, so they have, instead of static atoms, they have these atoms with all of these pieces moving all over the place, and then they describe these fields, and then they start saying there's more than just the electric field and the magnetic, and the magnetic field. They start talking about all kinds of other kinds of wacky fields. And, that's when, just my brain just shuts down and says, what are you talking about? Fields of what? You're describing some sort of ether. Well, okay, go ahead. Explain to me what it's made out of. How does it work? And it also seemed obvious to me that, well, what's all these planets doing? Well, they're crushing under all the pressure. They're obviously, the sun is crushing pressure, right? The inside of the sun is crushing pressure. It seems kind of obvious that there's something from the outside heading towards the inside. Everything is being smushed into each other, and that things are attracting by gravity, which is the same idea as that I put two things in this field of crushing pressure, and they end up drifting into each other because there's more crushing pressure out here than there is between them, so they all smash together. And I'm saying, well, that's just too obvious. So the force is in the thing here. The ether can't just be a transmitter. It can't just be like, oh, well, here's a little blob, and here's a little blob, and here's a little blob, and here's a little blob. And they just send a vibration through the blobs, and that's how you get the signal. You square this one, or, you give this one energy, and then it passes the energy to this one, then this one, then this one, and then you end up with the energy here. That's not pressure. Because then I still have to produce it somewhere. Somewhere I have to be producing all of this push. And so the obvious thing became, no, they're all X's. They're all energy. Okay? These are all energies. Okay? The force is all energy. It's nothing else. It's just energy. It's just energy. And then this is all kind of obvious. You make a field of random energy, energy going in all kinds of directions, randomized, whatever, and it's going in all kinds of directions, and guess what? You place anything in that field, and it's going to look like this. It's going to look like every arrow is heading right for it, okay? It seems like, right, everywhere I look, everything's heading right for me. Every one of those photons is heading right for me. It's amazing. Well, obviously they're not heading right for me, right? Because I'm not standing over there where they're heading right for every spot. They're heading right for that spot, you know. No matter where I put something, they're all heading right for it. So it just made so much sense that, yeah, the universe is just made out of this pressure. All of this little stuff moving, and it's all banging, pushing everything into clumps. And that's why the universe is clumpy. It's because the force is clumping it. All right, then you get into... All right, well, let me think, and I'll think about if there's something else that was a key thought. But I mean, the big one was the photon. You know, that one just made me doubt physics so much. You know, when they said that crap about this field thingy, magnetic, electric thing, when it isn't bent by electricity, it isn't bent by magnetism. If it's made out of those fields, then damn it, you should be able to affect it somehow with a magnetic field, but it's not affected. So why are we saying it's that? It doesn't do any of that electromagnetic stuff until it hits a surface. It doesn't have any electromagnetic property until it hits something. So obviously the electromagnetic thing needs atoms. You have to charge the atoms with the photon before the atom can have the electromagnetic properties. And again, that was the other part of it, is what is the nature of magnetism. And yeah, and I didn't have a source for that in the beginning, because you're still trying to figure out how you make the plus and minus besides polarizing a whole atom. But obviously, if you understand the neutron is the first dipole, well, then you can sort of understand how you can build little dipoles inside of an atom. You don't need the whole atom to be polarized. You just need the dipoles inside of it to be polarized. Just like a piece of iron. You know, you can switch it from being inert magnetically to being a magnet. Okay, and what are you doing? You're not giving it more energy. You're not doing anything specific. You're just changing the arrangement of little pieces inside. And so that was another huge giveaway, that if all I'm doing is turning something inside, then I'm just changing how it looks. I'm not changing what it is. I'm just changing, you know, appearance. You know, that if I spent everything, that I could understand that, well, yeah, that's going to just make it, if it was in a field of pressure, that's just going to make it look different to the field. And then it became easier to see that magnetism isn't radiation. It isn't a form of radioactivity. It isn't something that's coming out of the object. There's no energy producing it. So that was a key thing that I sat there, I could argue for decades with that question. How could a magnet appear to be creating some kind of energetic effect without using any energy? And it you know, somewhere in the last 10 years, it occurred to me that the answer was, it's not generating anything. It's just reflecting the universe different. And by reflecting it different, it's sending a signal to other things that are polarized. Okay, they'll see that the pattern of force is different. So where it was pushing on the bottom and the top would flip, it's now pushing on the top and the bottom is flipping. That kind of thing. All right, so take a little pause. I'll think if there's any other key point I have to make, and then I'll just draw the charge argument. All right, should be back. So I was thinking of general relativity is another thing where, you know, was just, nah, this isn't right. Because force, right, the speed of the forces all turns out to be the same speed as the speed of light, and so it's actually the speed of force. So that was something that stuck in my head more than a decade ago. And you know, that whatever the elemental universe is, it seems like it's all made out of the same stuff. It's just in a different shape, a different form.
but the stuff making stuff happen is this force stuff, and gravity has to be one of them. And the whole idea that physics separated gravity as some sort of special bent geodesic thing that didn't have anything to do with electricity and magnetism and light, and somehow was made out of some other substance that just happens to move at the same speed, it just seems so unrealistic and so anti-elemental. So the idea is you want to try to think in terms of like an evolution, and trying to think of how it starts with something simple and then it just adds on and it adds on a feature and a feature, and that the elemental bits are something like Legos, that it is just made out of something simpler, just like the atoms and the electrons made us, and they're just simpler and more mechanical, and it just seems so wrong to create all these different kinds of stuff doing different things, and they just happen to do them with the same little features in common. It just doesn't make any sense to me. So and it did make sense that it's really got to be that it's all the same stuff, and so separating gravity from the other forces just seemed like a gigantic error. This couldn't be anything else but an error, a mistake, that it has to be as fundamental as magnetism and electricity and light. It's as fundamental. Well, anyway, so that ruined a lot. So then the real job that I spent a good deal of time trying to figure, you draw it and you draw it and you draw it, was try to, how to figure out how to make charge. This idea of not just something attracting, because the push will do that. The push universe makes things attract. But how do you make them repel? So that took quite a while and a lot of thinking, and unfortunately you try to do some of the thinking in terms of what they've told you about things orbiting and spinning and doing all this stuff, so you're trying to make that model work. And it wasn't until I really said, let's just start over and take it step at a time, that I started thinking about the force as being the only source of energy. And so this is, it's sort of a, you have your choice of how to think about how things happen. So when I started drawing it and thinking about it, and I'm saying, okay, well, there's different ways this could happen, right? You could have a force bit that flies into something, and then it stops, okay, and the something gains the motion, all right? But that has the problem of what happens to all these little bits that stopped. Now, they could become matter, they could become things that don't move, but there's no evidence that there's these little dead bits of force in the field somewhere. So that didn't really work. And the idea that the motion is still would have to be explained, that what's causing it, and something distinct about the part that is energy, and the fact that it is reused and it just keeps moving through a system, also made it kind of, that to some point you have to accept the idea that things capture force. The idea of, I thought a lot about wrenches flying through space. You throw the wrench, and what's the difference between the wrench on the ground, on the earth sitting there doing nothing? Well, it's moving, it's doing a lot of stuff, but it's not doing any visible stuff. It won't just fly in space. It doesn't just jump off the earth and fly somewhere. And the wrench that's flying through space, and the difference is one of them's got to be different in some elemental way. And so I concluded, sort of, that force must actually be possessed by objects. Like, they have to have the force. They collect it. And that made gravity make a lot more sense in terms of how things gained force by falling. I mean, why is falling make something have force? Why is motion make something have the ability to make a mess when it hits the ground? It's because, well, it collected something, and the something is going to pop out when it hits the ground. So it collected it. It didn't have any here, but by the time it gets here, it's full of it, okay? And then it releases what it has because it stops and something else moves. So that all made sense. So, so the real thing was this idea of the electron and proton became what I understood to be the real essence of the universe, was explaining plus and minus. Because if you explain plus and minus, you sort of know that you're getting awful close to north and south. So if you can figure out plus and minus, you're going to get close to magnetism, because that's a dipole essentially. And so the simple solution just happened to be that you try to figure out all kinds of ways of doing it with just one force, and there's just no way to be able to make the two objects behave to just one force in inverse ways. But once I said, okay, well, what if there was two kinds of force, just like there's two kinds of matter? Well, then I can have the difference in the interaction. That is, I can have the electron force will stick to an electron and proton force will stick to a proton, but the inverse won't happen. And so then it was just a trick of figuring out, well, what happens when the inverse happens? What happens when one of these hits this? And so I had all kinds of ideas about different ways that could happen, and eventually realized that the simple solution was to have it just pass straight through and just have its identity change. So if a red bit goes into, if a proton bit goes into an electron, it comes out as an electron bit, and vice versa. If the electron bit goes into the proton, it comes out a proton bit. And so that creates what you see in Maxwell's drawing, which is something that just radiates one kind of energy. A plus is just radiating the plus, and the minus is just radiating the minus, because either the energy sticks or the energy reflects, the blue. So the electron force either sticks and moves it, or if it's already moving against that flow, it reflects. So it's either going to be, it's always going to be just radiating the same electron force. So electrons are always radiating electron force, and protons are always radiating proton force, and therefore this force is inert to this, and this force is inert to that. So you can understand why there's plenty of red over here pushing this one, and there's plenty of blue over here pushing this one, but there's no blue hitting this one, and there's no red hitting this one from the other side. So obviously they would smash into each other. And also obviously the electrons and the protons would hate each other, right? Because they're going to be hitting with a force that either gives it momentum in this direction, or it reflects and comes back and hits them. So they're going to repel. And that was just, once that fell into place, I'm saying I'm certain they're wrong. I'm certain the truth is something simple like this, because it's just so simple and it explains it so completely that, you really don't have a reasonable choice in terms of saying this is what it should, this is what the right answer should look like, is I guess the argument. And they don't have any answer for this. Their physics can't come up with anything. It's just some sort of mystical fields that somehow these mystical fields cause these opposite reactions, but there's zero explanation for how those fields work, and how it creates all of the pressure inside. And then you can do, like I said, once you build atoms out of these, okay, it becomes obvious that all they are is arrangements, geometric arrangements. And if I had a positive and net positive nucleus, you could understand why electrons would be stuck in positions, because if this one tries to get closer, you could sort of understand, well, it's kind of hard to see that. If this one tries to get closer, you could see that it's going to get more pressure from these. So the closer it gets to the electrons, the more repulsion it gets. So it's going to find a balance, and they're all going to balance each other. So I just create different geometries, and those geometries will dictate the spatial arrangements of the electrons, and it becomes perfectly reasonable that there's only so many configurations of nucleuses that I can create that can make that happen. And then you can just, like I said, you just keep adding features. So once you do this, then you create the deuteron. You can either do it with 2 electrons and a proton, or a proton and 2 electrons. I really should just, erase, but I won't. And then you can figure too that there'd be a bunch of energy can be stored
inside of them in terms of motion, and it creates all kinds of ways to overcome drag. But you can understand I have lots of pressure, and if I were able to knock this electron out, then the two protons would have a ton of energy repelling each other, and they could fly out of the atom with a very high speed and basically be pushed, okay, by a bunch of force. And the force will encounter stuff coming at it, and it will lose energy with distance. So the more time it goes through the force, so the more time it hits, the more stuff it hits, the more energy it loses. But it could have quite a bit of energy as its tail, so to speak, pushing it. And so it could take a while for it to use up its energy. Gamma ray behind it, powerful X-ray behind it. It's just pushing it. And that explains a lot of what they see in accelerators. So, it all fits. And all of it is, I'm saying that they didn't get the model of the atom right. They didn't get gravity right, because they've turned it into something that isn't even real as a functioning mechanism. And the whole idea of time as a dimension fails. I mean, the 3 dimensions do have a rule. I mean, it's 3 physical dimensions. Time doesn't fit as a physical place. You can't find time, in a location. It just doesn't make any sense to consider it a spatial dimension. So even that, why do math with 4 dimensions when the 4 dimensions aren't the same thing? They can't be the same thing. So even that fails. And then the kinetic energy thing came up a few years ago. I didn't really realize that physics actually believed in something called the kinetic energy theorem. That they thought velocity was a squared function of energy, and that somehow it wasn't just momentum. I mean, I thought momentum ruled the world. And remarkably, you go research it and you find they just don't have any evidence for this stuff. It doesn't fix any part of physics. It never did anything in the history of mankind. Kinetic energy didn't move anything with a lever, or didn't do this and didn't do that. It never did anything. It's superfluous to anything vital or functional. And the only thing it does is provide the opportunity to create preposterously unequal energy equations, where they can make tiny little particles going very fast have as much energy as entire suns. It just doesn't make any sense. What else? Yes, it's like every level of the physics, they just start with wrong assumptions. Then I could go into the whole photon thing with the wave interference and just not recognizing that there's just a simple difference between things. It's just this idea of being in phase, being in alignment and being out of alignment. And that's all there is. And when it's out of alignment, it's invisible. When it's in alignment, it's visible. And you can see that. The polarizing film proves it. You can take your 2 pieces of film, put them across each other, and no photons are coming out that you can see. None of them, but they're there because, frankly, the film isn't melting, so we know the light isn't stopping in the film. So it is going through, but it's going through in some form where we don't see them anymore. The photons are invisible. And all you have to do is put a 3rd film in, and all of a sudden you get 25 or 30% of your photons back. I mean, obviously they were always there, and all they were was out of alignment. They were just broken, and you just take the pieces and realign them, change their phase. And that's what the polarizing film does, actually. It's all transparent film, and all you're really doing is changing the phase of the photons. You're not blocking it, you're doing anything else. You're just changing the phase of bits of the photon, and then you're taking those bits and putting them back in phase. Simple explanation. Oh, even the expansion of the universe, right? They tell us the whole universe is expanding because light is shifted, and then you hear this vague peep in the background where people say, well, maybe it's just tired light, okay? Maybe the photons are doing something as they're traveling billions of light years that's degrading their frequency. And that's the explanation, that the
there isn't a true redshift. The redshift is being created by the travel. And the simple explanation is that there's a bunch of hydrogen atoms, in fact, in space. Empty space isn't entirely empty. And that photons traveling billions of light years are likely to encounter those atoms and likely to be scattered a little bit by each one of those atoms. And that little bit of scatter degrades the frequency a little. So, simple explanation works. But they always choose the complicated answer, and they always have chosen. And so anyway, I'm just explaining, these people who think there's some other agenda, then my argument is a simple one where what they're saying is the truth sounds like a UFO theory. It sounds like Sasquatch. It sounds like pixies and gremlins. It doesn't sound like an elemental evolution theory. It sounds like you're saying there's all kinds of mystical functions in the small universe. So instead of being simpler, much simpler than our world, somehow it's got features that are much more complicated than any feature we have. Somehow the electrons have ESP, but we don't. It's borders on ridiculous. But anyway. So that's probably enough of a video. So just making the point that these people who attempt to argue that there's some other agenda here, that I'm lying, that I'm doing something deceptive, some kind of, it's all bullshit. It's just these simple facts. The fact that it doesn't bother you, okay, that they draw a squiggly line and say that's a photon, or they tell you there's quarks inside of the proton, but they can't show you a picture of a quark, because it's a theoretical object made out of a synthetic bunch of numbers on a piece of paper. It's not something that they can represent in any kind of drawing. They can't show you how it works. They can't show you what it looks like. They can't show you even the evidence of it. They can't even show you the footprint. They can't show you the fossil. If they told you there was dinosaurs and they never showed you a fossil, you're going to believe the story? They just say they existed? Yeah. So it's like dragons or something. Somebody tells you they existed. Now you're going to want to see one of the eggs or something. But anyway, so the fact that you're convinced, and in spite of all the history too that I went through, the fact that they are misquoting Newton overtly, that they're not acknowledging that mv squared is Leibniz's idea, and that the only reason why people believe it is because of a bunch of show physics experiments that weren't very well thought through, and and that's all they have, and they don't have any hard evidence. You believe. Well, that's, in my opinion, that's your bad, not my bad. That I didn't fall for stories that aren't really well evidenced. Again, you research the Eddington experiment, fundamental to Einstein's credibility, and the experiment's a piece of garbage, and never repeated in 100 years, in spite of all kinds of opportunities. And then from space, it's a no-brainer, 400 times better resolution, you don't need an eclipse, and it takes 5 minutes. And I'm supposed to believe there's some good reason NASA hasn't attempted it in 50 years, when it takes almost no financing and no effort. It's the simplest of experiments you could almost do in space, and they haven't done it. And it's critical to Einstein's theoretical suppositions about bent time dimensions. So anyway, that's enough. So anyway, it's got kind of video just pointing it out, and I'll just continue to make all these other arguments, blah blah blah. But yes, it seems, like I said, physics is the worst science ever. It's just a religion. They just keep pounding their Bible, their textbook. They don't care about evidence. They don't care about showing or proving. They just care about propagandizing and convincing with authoritative, demands that somehow they know what they're doing. And there's just little evidence, in my opinion, that they do know what they're doing, because their answers are from silly to stupid. You know, and not they don't seldom do the answers go anywhere credible. So, till the next time and such, and so forth and whatnot. Yeah, that's enough. Yeah, it's enough.